Hi, and welcome to the presentation of the Robbins 34R QRS. My name is Johnny Lili, and I'm product manager for race boring and mechanical rock excavation, which Robbins is a part of. We will talk more about that in the presentation. So we will divide this one into 4 parts. The introduction of race boring, main benefits, technical specification, then a very short summary. So let's start with an introduction of race boring. So not everybody knows what race boring is, so I will start with that, so at least you get a small understanding of the concept of race boring. So when drilling holes, this is what race boring is, drilling holes and drilling large holes. So that is normally done with the race boring method is done in 3 different variations. We have the conventional race boring, which means that you have the machine on one level and you're going to make a hole to another level. This could be from the surface down to the main shaft or main tunnel in the mine or in a road tunnel, or it can be between 2 different tunnels in the mine. That doesn't really matter. So conventional race boring, meaning that the machine standing on the top, you drill down using this drill string here, drilling down to the lower level. You connect a reamer and pull that one up. That's the name, race boring. You're raising the shaft. 99% of all the races is done in this way. It allows for very long holes, over 1,000 meters long, and diameters up to 8-9 meters. So it's a very effective way of doing long, large races. A variant of this called down reaming, and that, as you can hear on the name, is going downwards instead. You still need access to 2 levels, because you pilot down, you take the drill string up, then you put on an enlarger or a reamer that you enlarge on, and you push that one down, and all the cutting stems falls down through the pilot hole. Now you need this pilot hole here because you're normally using water or air to get the cuttings out when doing the pilot hole. But when doing a larger hole like this, there's a lot of volume here, so it's difficult to get the cuttings out that way. Therefore you need this pilot hole first. This method is normally used when it's not safe to access the lower level. Could be like a form of easer hole or slot hole for blasting against when you want everything to cave downwards. That's one example. The third method is called box hole boring, and that is done upwards. Now this can be done blind as we call it, meaning we don't need to drill a pilot hole first, but you have a pilot bit sitting in the front of the reamer, and you're pushing the drill string upwards, all the cuttings fall down and is deflected by this muck chute here, or box, where the name box hole boring comes from. Goes out on the side. Normally not that long holes, maybe up to 50 meters. And this, you don't need access to the upper level. You can do it straight up in the ore body or what you want to drill in. These 2 methods is not that common as conventional, as I mentioned, but we're seeing more and more of this down reaming being done, especially in production drilling, where you need a larger slot hole to blast against. We have the machines called easer for this, for example. Now the reamer here, this is mechanical excavation, meaning we're not using any explosives or blast methods. So the reamer itself, it looks like this. So there's a big steel structure, and on that is a number of cutters. And these ones are pushed against the rock and then rotated. And then you can see that this cutter here creates these cracks. You can actually see these ones here also. And these are called curves. Now, this is the machine on top pulls the reamer and rotates it at the same time, creating this force. So the cutters are rolled over the surface. When the cutter here is rolled over the surface, there's a lot of small knobs sitting on here. Now, these knobs here pushes into the rock, and right under here you actually crush the rock. But what's happening when you push this knob in, you create a pressure bubble here, and you get tensile failures that creates cracks in the rock. Now, when you have two rows here, you have cracks from both sides coming, and when they meet, the rock ships out, and you have curve breaking. And this is the principle of this. This is how you actually get an advance. Normal advance is about 2 to 3 millimeters per revolution, and the reamer spins about, depending on size, then but 10-15 RPM. So that's how race boring works. And the result then, this is the result. So you can see that you actually get a very smooth surface here. It's excellent for ventilation. There's very little friction in this. And this is what race boring mostly is used for, ventilation shafts. But it can be used for other things as well. So hoisting, slot holes that we talked about earlier. The smoothness is one good thing about this. Another good thing is that you have an excellent hole straightness. The deviation is very, very little. I would say it's about, when doing conventional race boring or pilot drilling, you have less than 1%, meaning that on a 100-meter hole, you have less than 1 meter deviation from the pilot bit. If there is a need for super straight holes, there are steering tools to use, and then you're usually within centimeters on several 100 meters long races. Also the impact on the surrounding rock is very little. These races tends to hold up very well due to the circular geometry, and also that we don't introduce any cracks as we're not blasting anything. Main benefits with the Robbins 34R QRS. So QRS, quick race bore setup. Take the whole name here. Robbins, all our race boring machines called Robbins, comes from the Robbins Incorporated. 34RH, the 3 stands for the size of the reamer that this machine can pull, and the size in foot. This is an old number that we might have outgrown, but we are familiar with that name or series, how large reamer we can put. Number 4 here is second number is the generation of machine. We're trying to develop these ones as being in the forefront of technology. R stands for race boring, and H for hydraulic drive, which means the part that rotates the drill string. So it's a machine that is built for quick setup, meaning you don't need a concrete pad to to set the machine up to. The machine has built-in jacks for leveling it, stinger cylinders for bracing it, and other functionality to ease the setup as much as possible. It's designed to do a down reaming. That's the main purpose of this machine. As we talked about before, down reaming is when you're pushing the reamer downwards. And it can handle reamers up to 720 millimeters. It can also do raise boring if needed. Then it can do a conventional pilot hole and pull the reamer back up to, and that it can do up to 1.5 meters in diameter. But as I say, main purpose is down reaming for slot holes or easer holes. We're trying to be a quick setup, we don't want to prepare the drill site as much. A lot of things is built in then. So we have the base frame here with jacks to level the machine. Stinger cylinders built in, 2 of them that pushes against the roof to lock it in place. A crane for pipe handling and for lifting the reamer, pipe loader, reamer and stabilizer and pipes. Everything to smoothen the operation as much as possible. Well, the derrick is mounted on this base frame, and this base frame has the jacks built in to level it. It also has a turntable, meaning that you can put your hole in an angle and also rotate it. So if you come into the drift and you want the hole that is in like 90 degrees perpendicular to the drift, you can actually rotate the derrick on this base frame. It also has hydraulic wrenching built in, both in the table and in the drive head. So there is no manual lifting of heavy parts here. We're using our Epiroc control system, which is called the RCS rig control system, and has been used for almost 20 years now. It really aids the operator in the daily work. It prevents the reamer from stall. It has a very good anti-jam system built in. It logs all the torquing of the pipe, which is really important, and also monitoring the torque to see that it tightens the threads properly. A lot of information built in, automated functions, monitoring system works really good. Technical specifications. So we talked about before that the name is 34RH, and the H stands for hydraulic, and that means hydraulic drive. So on the derrick here there's a hydraulic motor, and it's an Hägglunds motor that is high torque, low speed, which suits our application very well. That motor is powered by an hydraulic pump, so it's a hydrostatic system, and the pump is powered by an electrical motor, and that sits in this power pack here. The power pack also feeds all other hydraulic functions like thrust cylinders, stinger cylinders, jacks, etc. We have a wrenching system that is semi-automatic or hydraulic driven, so there's no need to lift in any wrenches. So this is the drive head wrench. I think we can take a look on how that works. See, so the wrenching works that this hub goes down, and there's a ring that's pushed down, which push in 4 blocks and locking the pipe, so you can do the breakout and makeup you don't need it for, but for the breakout you need to lock the pipe so you can break the lower joint. Very simple design and function, works very well. And then down in the work table there's a wrenching system that is hydraulically operated as well. Pipe loader, we touched this a little bit before, but the pipe loader itself is just a swing in, swing out arm. A very simple design, but it actually puts the pipe in the exact center, and it can also handle the reamer, the 720 millimeter down reamer, and all stabilizers and pipes as well. Then we have the crane on top here that folds when in transport, and can cover quite a large area in front of the machine. All controlled by a tethered remote. We talked a bit about base frame before, but we can talk a little bit more about the turntable then. So the sketch here shows that when the derrick has been raised here, then you put in that angle that you want to have the hole, then it can be turned either clockwise or counterclockwise, about 100 degrees in each direction, to get the hole in that direction that is wanted. The RCS comes, it's a control system. We also have this radio remote, so we can operate some of the functions from a remote control. We can't drill, but we can do all the pipe picking. If you need to pick up the pipes, maybe you want to be in the front there working at the same time, then this radio remote is aiding for that, helps a lot. Fully built in with the RCS control system. A short summary. Well, the Robbins 34RH QRS is a quick raise bore setup machine, and that's thanks to the built-in jacks and stinger cylinders that helps mobilize the machine in a very quick way, as you don't need a concrete pad and you don't need to bolt the machine down to the ground. It has the built-in crane to handle the pipes and the reamer. It has an excellent hydraulic drive system and control system that aids the operator during the operation, preventing errors like spin back and stall, reamer stall. It has the built-in opening of the work table, so you can do the down reaming up to 720 millimeter holes. The pipe loader and the crane can also handle that pipe, that reamer, that 720 millimeter reamer, which is excellent. So QRS, a quick raise bore system, well, yeah, that's it. That's a short summary. Thank you very much.